All right, I want to talk real quick about the difference in first derivative test and second derivative test because there's a little bit of confusion about what you're actually doing with those. So first derivative test, I think we're pretty well straightforward on. So for a first derivative test, you are looking for critical numbers. And critical numbers happen where f prime is equal to 0 or where f prime is undefined. That tends to be the one that you forget about, but you need to make sure you include that point as well. Once you know your critical numbers, if f prime changes from positive to negative at that number, that means that critical number is a maximum. If f prime changes from negative to positive, that means that critical number is a minimum. And that's where you've seen us do things like, okay, so we draw this number line represents f prime. We'd put like the first number here, the second number here, and we figure out like negative, positive, negative. If it's negative, that means it's decreasing, positive is increasing, negative is decreasing. So that would mean A would be a min and B would be a max. So that's how we've used the first derivative test. If it doesn't change from positive to negative or negative to positive, like if the sign stays the same, that means that it is neither a maximum nor a minimum. And that would be something like you've seen a graph do like this. Right there, the first derivative is equal to 0, but it is increasing, and then it changes back to increasing. So that's not a maximum or a minimum, but it is still a critical number. So if we look at this question down here, we want to find the relative mins and maxes for that. So you take your first derivative. So that would give us 12x cubed minus 12x squared. You're looking for where it's equal to 0 or where it's undefined. That's a polynomial, so it's always defined. So we just set it equal to 0. Then we find what x values are. So you factor out what they have in common, or you just factor it in general. So they have a 12x squared in common. So when you take out 12x squared, you would be left with x minus 1. So from this one, you get x equals 0. From this one, you get x equals 1. So this is where we do our number line. That is f prime. Our critical numbers are 0 and 1. So you would be thinking about plugging in something in between those numbers. Now I tend to focus in right here because it's factored, and so it's pretty easy to think about plugging things in there. So if you plugged in like negative 1, 12x squared, x squared means it's always going to come out positive. If you plug in negative 1 and negative 1 is negative 2, so positive and negative means it is negative. So it would be negative everywhere in this interval, so it is decreasing. If you plug in 1/2, again, 12x squared is always going to be positive. And then if you plug in 1/2, it's going to come out negative, so that is still negative. So that still is decreasing. Now if we plug in like 2, when you plug in 2, that's always positive, but now this is positive as well. So that means this would be increasing. So this is just a critical number. It's not changing from positive to negative or from negative to positive. So it's just a critical number. It's not a maximum. It's not a minimum. This one, though, changes from negative to positive. So if it changes from negative to positive, that's going to make it a minimum. So this graph would have no relative maximum, but it does have a relative minimum. If it seems kind of odd to you that you have a critical number where it doesn't change from positive to negative or negative to positive, just look at the graph of it when you look at the graph of it, this is going to be a bad picture, but it looks something like this. So you can see here it kind of levels off, but it's decreasing and then it's still decreasing. Here it levels off, but it changes from decreasing to increasing. So that's first derivative test. That's what we're used to. Now, second derivative test is different. The second derivative says if f prime is equal to 0 at some number c, and then if f double prime is less than 0 at some number c. This means it is a critical number. You know it's a critical number because the first derivative is equal to 0. Now, second derivative being less than 0 means it's concave down. So you already know it's a critical number. So if this is a critical number and it's concave down, that means it's going to be a maximum. If f double prime is greater than 0 at x equals c, that means it's concave up. You already know it's a critical number, so that means it's a minimum. So with second derivative test, you know that the first derivative is 0, then you're trying to see is it concave up or concave down. So this question down here says, is this point a max, min, or neither? Well, if it's going to be a max or a min, it needs to be a critical number, which means the first derivative has to equal 0. So if we plug it into dy dx, we end up with 4 minus 4, which is 0. So it is a critical number. But what we've got to decide from there is it going to be concave up or concave down? So for that, we need the second derivative. So this is defined implicitly, so we need to make sure we do that. So the derivative of x squared is 2x. The derivative of y is dy dx. Now we want to plug in that point negative 2, 8. So 2 times negative 2 gives us negative 4 minus 1/2. We already know from up here that dy dx is equal to 0, so that means it's just negative 4. So if it's negative, that means it's concave down. So this point is going to be a maximum. So second derivative test doesn't really tell you like concavity intervals. Second derivative test is still looking for whether something is a max or a min. So you'll see a little bit of stuff like that on your work for this week. So if you have any questions, please reach out and let me know.